Before we jump into chapter 4 though, are there any questions that you guys have either from your review, from the closure, anything from chapter 3, because you have your test tomorrow? So anything we need to go over before we kind of move on? Now's your time. You can type it in the chat personally, and if you'd rather just stay after class and ask a couple questions or two, you're welcome to do that as well. Otherwise, we are going to start chapter 4, which is on statistics. We're gonna not do all of chapter 4. But we are gonna kind of jump around a little bit. Sorry, I'm just replying to a couple of chat messages. Okay, so just trying to clarify with a couple people what they wanted me to go over. Let me. Your CUDA works is due. So the assignment for CUDA works is due tomorrow by 10 a.m. before you start your test. Your work for it though, you will just turn in when you turn in your assignments on Monday. So just kind of make sure that'll be part of, because your assignment is kind of broken into 2 pieces just to get full credit. Make sure you turn that in on Monday. Also, something I want to point out about work, as far as your work goes, if you're not done by 10 a.m. on Monday, turn in what you have, because otherwise all of it is marked late. If you have your classwork done and just didn't finish the homework, turn in what you have. When I return it to you, I'll tell you what's missing, and you'll probably already know. But then you can at least get full credit on the parts that are there rather than getting late credit on every single piece. So if you have part of it done, even if it's just the classwork, remember classwork is 5 points, homework is 5 points. If you have your classwork done, which if you're here when we're going over it, you should, you'll get those 5 points if you turn it in on time. If you turn it in late, you're only going to get 3 points for your classwork, even though it was done on time. So make sure you turn in what you have on time. Okay, so somebody asked me to review a trig word problem. So let's say a 17-foot tree makes a 12-foot shadow. What is the angle? Let's see how I want to word this. From the top of the tree to the ground. So a 17-foot tree makes a 12-foot shadow. What is the angle from the top of the tree to the ground? So this, here would be, so we'd just make our right triangle. So our tree would be 17 feet here, and our shadow is 12 feet. So this is clearly not drawn to scale. And we want to know the angle from the top of the tree to the ground. That's going to be this guy up here. I'm going to use theta. So as a reminder, hopefully we all remember SOHCAHTOA. If we're using this angle theta, the 12 would be our opposite side, and the 17 would be adjacent. So that lets us know we're using tangent here. So tangent of theta would be 12 over 17. So depending on kind of how you were taught this, essentially you're taking the inverse on both sides, which you just write tan of -1 in front on both sides. And that makes these two cancel out. So theta would be tangent inverse of 12 over 17. You will want to make sure your calculator is in degrees, not radians. So tangent of 12 divided by tangent inverse, sorry, 12 over 17, that would be about 35.2 degrees. Okay. Anything else that you guys want me to review? Okay. So let me share the book real quick. So this, we're going to start talking about survey design. Have you ever heard statements like this? 81% of public schools are not satisfied with the food provided by their schools or students. Sorry, I left that word out. The president has an approval rating of 72%. So those are kind of standard statistics that you'll hear, but how did the news sources get this information? Did they ask every public school student? If they're talking about president rating, did they ask every citizen? And what questions do they ask? Are their results reliable? Do you believe them, and should you believe them? So we're going to learn kind of some about this. We're not really going to go do problem number 1 because problem number 1 wants you to make a research question that we would essentially ask around the school, but we're not going to do that. So, but just to review on number 1, population, that's going to be the entire group rather than a sample. So, you know, if you wanted to know something about all 9th graders or about 9th graders at Benicia High, you could ask every single 9th grader if you wanted to. Or you could take a sample and just ask certain students. You just have to be careful about what students you are asking. So for problem, we're gonna do 4-3 and then come back and look at 4-2. So these are types of bias in survey questions. And I'm actually just going to write them in our notebook kind of as like a mini notes. So types of bias in survey questions. And this pretty much is coming from your book. So question order is that the survey questions are written in such an order that one question leads you to an answer on the next question. So in question order is the survey questions are written in such an order that one question leads you to an answer on the next question. And we'll look at examples of all of these in just a minute. And there's preface, which is the question starts with a leading statement. To lead you to answer a certain way. The next is two questions in one, is that the question is written in such a way that you want to answer yes to part but no to another. So the question is written in a way that you may want to say yes to one part and no to the other. But there's only one answer. So biased wording is pleasing or unpleasing words, or pleasing or unpleasant. Better choice there. So pleasing or unpleasant words are used to lead you to answer a certain way. And the last one here is desire to please. So this last one, the desire to please, is the respondent feels they need to answer the way the surveyor wants. All right. So we'll give you guys a little bit of time to finish copying these down. Like I said, then we will talk about them and look at examples. Sorry, 15. Some astronomers believe that a number of small objects called volcanoid asteroids exist between Mercury and the Sun. Other scientists, however, do not believe these asteroids exist. The brightness of the sun has prevented direct observation, so the controversy remains unresolved. Imagine the following scenario. Scientists invent a special camera that can photograph these asteroids even though they are so close to the sun. They put the camera on a satellite and send it off. To their joy and amazement, the satellite begins to transmit images back to Earth and the asteroids are visible. Volcanoids are real. Unfortunately, in just 5 seconds, the heat of the sun damages the camera and the transmission stops. Due to a technical malfunction, the 5 seconds of video images are not recorded. The scientists who are watching have to rely on their memories of the images. So basically, they sent this camera off to space to take these images, and it popped up, but then it went away. And so they didn't record it, basically, and they just got to see it for 5 seconds. So what you're going to do is we're going to determine the size of a typical asteroid by modeling this scenario. And I'm going to show the resource page. I posted it online. If you did print it, if you printed it, you'll just leave it face down and then turn it over, or you can open it on your screen, but I'll display it up here. So what you're going to do is, like I said, not yet, you'll have 5 seconds to look at it, and you just want to say what you think the estimate of a typical asteroid is in millimeters. So let me share my screen again real quick. So I asked if you have a ruler that has centimeters on it. You're going to want to look at that right now. Let me get to a blank page so the words aren't in your way. So 1 centimeter would be 10 millimeters. Every little tick mark inside a centimeter counts as 1. So if you thought it was like 3.5 centimeters was the average, that would be 35 millimeters. Does that make sense? Hopefully. I can leave this up as well or come back to it. Again, you're going to have 5 seconds to look at this picture, and then you're going to say what you think the typical asteroid size is. And again, typical for you might not be the same for everyone. So let me go back to the book. All right, I'm going to pull this up for 5 seconds. All right. So you have 5 seconds to look at this. I'll scroll down in just a minute. There's only a couple more at the bottom to determine what you think the typical asteroid size is. Okay, So again, in millimeters, please don't go back and look at it. There's no right or wrong answer. Just say what you think it is in millimeters. So I will type these into my graphing calculator, and I have to wait. So I'm gonna need, there's 29 of you here, waiting for every single one of you to send me something in the chat saying how many millimeters you think it is. Remember, 4 millimeters would be right here. And so like 9 would be here, which is fine. And 20 would be 2 centimeters. So I'm typing all these in, so it's taking me a minute. I want to make sure I don't miss any. I think I'm missing 1 or 2, but I could have just missed them in the list. Okay, so I'm going to, what I did in my graphing calculator is I typed these into the list to make a histogram. That's essentially what we want to do here. So our smallest number was 9 and our largest was 70. So we need to make our histogram at least go from 9 to 70. So this is going to be, for A, I'm just going to label it as random. So since we need to go from 9 to 70, I'm going to start at 5 and count by tens. And we actually have to go to 75 because okay, turn it off. Because that's the way it's going to work here. So I'm going to set this up on my calculator. I have to change my window. Okay, so this is what our histogram is going to look like here. So I didn't make mine go up all the way. This one here, this first bin goes up to 1. This one, the biggest one, goes up to 9. So I'm going to count by 2s here. Okay. And so we're going to sketch this here. Why? Okay, so that's what it looks like. This was the number of people for the y-axis. This was the average asteroid size in millimeters. So now what you're going to do, and I'll come back to this in just a second. So actually, I'll just read the problem from the book for you. For part B, and we're going to do it a little bit differently just to kind of speed it up a little bit. Oh, and I was supposed to make a box plot with this as well. Not a box plot. Yeah, a box and whiskers. Mommy, I had it, but it wasn't too hard. Okay. So hopefully we remember kind of what a box plot looks like, or a box and whiskers. And these dots up here are going to be outliers, and then that's kind of the quartile 1, the median, the quartile 3, the min and max, again, ignoring the outliers. But for part B, nope, that was B. A and B are kind of together. Or that's all of problem 14, or 15, I should say, just kind of combined. So we can tell that this is not a very good histogram. Our data, we have a few outliers. I am going to get the average here. So to do this on the calculator, I'm going to do stat, calculate one variable statistics. So this tells us our average, that top one, the X bar, is 20.2. So that's the average from our data. And then the standard deviation, we're going to look at that SX, is 13.1. So that standard deviation, looking at the one with the S, that kind of measures how far spread out our data is. That should be a review from Math 1 again, but that's been a long time. The smaller the standard deviation, the closer our data would be together. We can see our data is really spread apart here. That's why our standard deviation is so high. So for problem 16, we're going to essentially do the same thing, except it's going to be an intentional selection. You're gonna, it says to pick 10 and then find the average. To save time, you're just gonna pick one. You're gonna tell me which one you're choosing, and I will measure it for you unless you wanna measure it yourself if you printed this paper. No, to be consistent, I'm going to open it back up in the book. Just pick what one you think is the typical asteroid that would be kind of, that I would measure. So tell me what asteroid number you want me to measure that you think, excuse me, is the typical asteroid size. Like I said, I'm going to type these in. It's going to take me a little bit longer because I have to measure them. But so you're going to have to, on your paper, set up the exact same axes again. Scale it the exact same way. You gotta wait a minute, baby. Why? Because I gotta finish my class, okay? So it looks like I'm waiting for about 10 more people. So I need this from everyone so we can get our data so that we can move on. Again, while you're waiting, set up your next set of axes the exact same way. Mm-hmm. Mm-hmm. Okay, so for time's sake, it looks like I was still missing 2 people, but we will go ahead and see. So this is what the graph now looks like. So this was our intentional selections. So again, I set up my axes the exact same way. So this first one's at 3, then we're down at 2 and 2. And if you measured 10, by the way, that's gonna be in this little second bar right here. It always measures kind of to the right. If your number was 15, and that would be the size, not the asteroid that you chose, it would be in this one here.
I have it right there.
Okay, Bunny. So here we can see the average is 26.7 and our standard deviation is 12.2. So our, sorry, 12.7. So our standard deviation went down a little bit, which we can tell from our data that it's a little closer together here. Our peak is higher. So by looking at this, more of you thought that the average was closer to 40, where when it was just a quick glance, more of us thought it was closer to like 15 to 20. So our perspective changed when we got to kind of just a quick glance, and here we got to choose one and say what size we thought it was. Then 4-17, and I'm going to kind of try to go a little bit quicker because we're getting kind of to the end here. So I was wrong. This first one we did wasn't random. This was called our quick estimate. That was when we just looked at it really quickly. And this one down here would be our random. Almost, baby. So for the random, what I did is our calculator has a random number generator. And you can also find one online. So from this random one, I'm actually just going to take some data from one of my last classes rather than otherwise I would have to. So I got these random numbers. So again, my calculator just gave me 27 random numbers between 1 and 100. I would have to go back and measure all 27 of those. And to save us some time, I'm just going to take data from the last time I did this. So again, this is picking my computer, or the calculator gave me 27 random asteroids between 1 and 100, and I measured those, and then I kind of put those on here. So based on this data, we can see that the average is 19.96 and the standard deviation is 5.02. Remember, standard deviation is how close together it is. We can see the data here is really close together. That's why our standard deviation is much lower. And then this average is much closer to the actual average. So the real average, if I did all 100 of those, would be 20.05. So we were actually, this random is really close. Our quick estimate at the very beginning was also really close. But when we got to choose which one we looked at, it wasn't as close anymore. It's typically going to be much farther off when you have a choice. And when you have random selection, it's going to be the closest to the average. So again, just to kind of recap really quickly, we talked about the different types of biases, and we kind of looked at examples of those. We had this asteroid problem where it said, okay, you have 5 seconds to look at it and then tell me what you think the average one is. And this is what our data looked like. Then it was, okay, now look at it as long as you want. Tell me what one you think is the average. I measured it for you. And this was our data, and it was more spread out, or our average was higher, I should say. Then when we just selected random numbers, we got much closer to the real average, and our data was much closer together. We'll talk more about these histograms, and then we'll also talk about the box plots next week. This is not on your test, so don't stress about it too much. The idea of these problems here basically is to say random selection is the best. Anytime you're doing some kind of survey, you want to ask random people. You don't want to get the same, you don't want to intentionally select people. You want to do it randomly. Maybe the 10th person, every 10th person on a list in alphabetical order or something. If you have questions, so tomorrow we are going to log in live for your test. The expectation is that your camera is on and kind of pointed down a little bit more towards your paper. When during the team test, I saw a lot of half heads and ceilings, not the expectation. You are allowed to use your notes and you are allowed to use your calculator, but those are kind of what you have available to you. Your test starts tomorrow at 10 and it has to be submitted by 11:30. So that's where we are with that. If you have questions, you can stay and ask them now. Otherwise, I will see you for your test tomorrow at 10.